April 2024, the Red Sea. USS Carney fires its 51st missile in 4 months defending against Houthi attacks, not 51 missiles in training, not 51 missiles across a deployment, 51 combat intercepts in 120 days, and every single one came from vertical launch cells that cannot be reloaded at sea. When those cells are empty, the billion-dollar destroyer becomes a billion-dollar target. It must withdraw from the fight, steam thousands of miles to port, and spend days reloading before returning to combat. That's not a logistics problem, that's a strategic vulnerability, and America's adversaries have built their entire naval doctrine around it. Because if you can force American destroyers to expend their magazines, you don't need to sink them. You just need to outlast them. This is the problem the Navy has been trying to solve for 40 years. The vertical launch system that revolutionized naval warfare by packing 90 missiles into a single ship, but trapped those missiles behind a design that makes reloading at sea nearly impossible. Until now. The Navy is testing something that changes everything. Not a new missile, not a new ship, a system that lets destroyers reload their own magazines while underway, turning magazine depth from a fixed limit into a renewable resource. Let me show you why this matters, why it's so difficult, and why solving it might be the most important naval innovation since the VLS itself. The vertical launch system transformed surface warfare when it entered service in the 1980s. Before VLS, destroyers carried missiles on rotating launchers that required manual loading and fired one at a time. The USS Spruance carried a single Mark 26 launcher with 24 missiles total. That was state of the art in 1975. The USS Arleigh Burke, commissioned in 1991, carried 90 missiles in vertical cells that could fire in rapid succession. Same hull size, nearly 4 times the firepower. VLS cells are arranged in modules of 8, installed below deck in armored containers. Each cell holds one missile standing vertically. When the ship fires, explosive gas generators eject the missile from the cell. The motor ignites after clearing the deck. It's fast, it's reliable, and it's been the backbone of American naval power for 4 decades. But there's a problem nobody talks about. Once you fire those 90 missiles, you're done. The ship cannot reload at sea. It must return to port, crane the missiles into the cells one by one, and then return to the fight. That process takes days, sometimes weeks, depending on port availability and munition supply. And in a sustained conflict, days matter. The Red Sea operations proved it. From October 2023 to February 2024, USS Carney fired over 50 missiles defending against Houthi attacks. That's more than half its magazine. If the attacks had continued at that pace, Carney would have been Winchester, completely out of ammunition within weeks. The ship would have withdrawn from theater, leaving a gap in air defense that other ships would have to fill. Now multiply that across a fleet. The Navy operates roughly 70 Arleigh Burke destroyers. In a conflict with China over Taiwan, those ships would face simultaneous attacks from anti-ship missiles, aircraft, and drones launched from mainland bases. Each destroyer carries 90 VLS cells. Some cells hold Tomahawk cruise missiles for land attack. Others carry standard missiles for air defense. Others carry vertical launch ASROC for anti-submarine warfare. A single ship defending against a coordinated attack might fire 20 missiles in an hour. If attacks continue over days, magazines deplete rapidly, and unlike bullets or torpedoes that can be transferred ship to ship through underway replenishment, VLS cells require cranes, specialized handling equipment, and calm seas to reload safely. You can't do it while underway. You can't do it in contested waters. You can't do it quickly. That limitation defines how the Navy fights. Destroyers must conserve ammunition, prioritize targets carefully, and withdraw when magazines run low. China knows this. Russia knows this. Their naval doctrine explicitly aims to force American ships to expend magazines through mass attacks, launch 50 missiles at a carrier strike group, force the destroyers to fire 100 interceptors, repeat until the defenders are empty, then launch the real strike when they can't respond. That's not theoretical. That's the operational plan. And it works because VLS cells don't reload at sea. The Navy has been trying to solve this since the 1980s. Early concepts involved crane systems that could lift missiles from supply ships and lower them into VLS cells while both vessels steamed in formation. The technical challenges were enormous. VLS cells are below deck. You can't access them without removing deck hatches, exposing the magazine to weather and sea spray. Each missile weighs between 3,000 and 4,000 pounds. Handling them safely in open ocean requires precise motion compensation and near perfect conditions. One mistake, one dropped missile, one wave at the wrong moment, and you've detonated a warhead on your own deck. So the Navy abandoned at-sea reload for decades. It was too dangerous, too complex, too expensive. Easier to build more ships and rotate them through port for rearming. But that solution doesn't scale. Building destroyers costs $2 billion each. Construction takes years. The Navy can't afford enough hulls to sustain magazine depth through pure numbers. And in future conflicts, port access might not be guaranteed. Chinese missiles can reach Guam, Okinawa, and other forward bases. Returning to port might mean sailing through contested waters where submarines and aircraft hunt resupply convoys. The Navy needed a different solution, and they found it in something unexpected: modular payloads. Instead of reloading individual missiles into fixed VLS cells, the Navy is developing containerized launch systems that can be swapped as complete units. Think of it like reloading a magazine on a rifle rather than loading individual bullets. The transferable rearming mechanism, known as TRAM, uses standardized missile containers that can be transferred from supply ships to warships using existing underway replenishment gear. A supply ship carries containers loaded with missiles. It steams alongside the destroyer. Cranes transfer the containers across. The destroyer integrates them into mission bays or temporary launch positions. You're not reloading VLS cells, you're adding magazine capacity through external systems. The concept isn't entirely new. The Navy experimented with containerized missiles for years, but previous attempts failed because the containers were too large, too heavy, or incompatible with existing ship designs. TRAM solves this by using standardized containers that fit existing UNREP equipment. The containers themselves become launchers, eliminating the need to transfer missiles into ship systems. A destroyer fires 40 VLS missiles defending against air attacks. Its magazine is depleted. A supply ship transfers 2 TRAM containers, each holding 12 missiles. The destroyer now has 24 additional missiles without returning to port. It's not as good as a full VLS reload, but it's enough to keep the ship in the fight, and that's the critical difference. Before TRAM, a depleted destroyer withdrew from combat. With TRAM, it remains combat effective while underway. The missiles themselves are variants of existing weapons: SM-2, SM-6, potentially ESSM quad-packed into single containers. The Navy isn't developing new munitions, it's developing new ways to deliver existing munitions to ships at sea. That approach reduces cost and accelerates deployment because the missiles are already qualified and integrated. Testing began in 2023. The Navy transferred prototype containers between ships, validated handling procedures, and confirmed the concept works in realistic sea states. The next phase involves live fire tests, launching missiles from TRAM containers to verify performance matches, VLS launches. If successful, the system enters production and begins fielding across the fleet. But TRAM isn't the only solution. The Navy is also exploring automated rearming systems for VLS cells themselves, robotic handling equipment that can remove hatches, lift missiles, and load cells without human intervention. The challenge is engineering reliability. Humans can adapt to unexpected conditions. Robots fail when conditions exceed program parameters. And the open ocean is nothing but unexpected conditions: waves, wind, ship motion, equipment malfunctions. Any of those can turn a routine transfer into a catastrophic accident, so the Navy is proceeding carefully. Automated systems work in controlled environments. Making them work at sea requires years of testing and refinement, but if it works, the implications are enormous. Imagine a destroyer that can reload its own VLS cells using missiles transferred from supply ships. No port visit required, no vulnerability during transit, just continuous combat operations sustained by regular UNREP cycles. A carrier strike group operates indefinitely in contested waters. Supply ships shuttle between rear area bases and forward units, transferring missiles every few days. The destroyers never leave station. Magazine depth becomes a logistical challenge rather than an operational constraint. China's strategy of overwhelming American defenses through mass attacks collapses because the defenders aren't running out of missiles anymore. Every few days, they reload, and the attackers face unlimited magazine depth backed by American industrial capacity. The cost is significant, but justified. Each tram container costs roughly $2 million. A fully equipped supply ship might carry 20 containers, representing $40 million in hardware, plus the missiles inside, adding another $80 to $100 million. But compare that to building another destroyer. One additional Arleigh Burke costs $2 billion and takes 5 years to construct, or compare it to losing a destroyer because it ran out of missiles. A ship lost in combat represents not just the hull, but the crew, the operational gap, and the strategic message that American defenses can be overwhelmed. Spending $150 million to keep existing ships combat effective is cheap compared to those alternatives. International interest is high. Japan, South Korea, and Australia all operate destroyers with VLS. They face the same magazine depth constraints the United States does. Tram offers a solution they can integrate into existing fleets without major modifications. Allied destroyers operating in coalition task forces could share tram containers through standardized transfer procedures. A Japanese destroyer depletes its magazine. An American supply ship transfers containers. The Japanese ship remains in the fight. That interoperability multiplies effective magazine depth across the entire coalition, and it complicates Chinese planning because they can't calculate depletion rates when allies continuously resupply each other. The timeline is aggressive. The Navy wants initial operational capability by 2026, full deployment across the fleet by 2030. That's fast for a system this complex, but the urgency reflects how seriously the Navy takes the magazine depth problem. Every war game, every simulation, every operational analysis reaches the same conclusion. In a sustained conflict, American destroyers run out of missiles before enemies run out of targets. Tram changes that equation. Not completely, not permanently, but enough to extend combat operations from days to weeks. And in naval warfare, weeks can be decisive. Critics argue the system adds complexity. More equipment means more maintenance. More containers mean more logistics. More moving parts mean more failure points. All true. But the alternative is worse. Without at-sea rearming, destroyers fight until they're empty, then withdraw. With tram, they fight continuously. The added complexity is worth it if it keeps ships in the fight. And the Navy has been managing complex logistics for centuries. Underway replenishment already transfers fuel, food, and ammunition between ships. Adding missile containers is a new challenge, but not a fundamentally different one. The cultural shift might be harder than the technical challenge. For 40 years, the Navy has accepted that VLS cells don't reload at sea. Doctrine, tactics, and training all assume fixed magazine capacity. Ship captains plan engagements around ammunition limits. Admirals position forces to maximize magazine efficiency. Tram requires rethinking those assumptions. Captains can be more aggressive knowing resupply is possible. Admirals can sustain operations in contested waters without withdrawing ships for rearming. But old habits die hard. Changing how the Navy thinks about magazine depth requires more than new equipment. It requires new doctrine, new training, and new operational concepts that exploit renewable magazine capacity. That transition takes time. But it starts with proof of concept. If tram works, if destroyers successfully reload at sea, if combat effectiveness increases measurably, the Navy will adapt. Because results drive change faster than theory. And the Red Sea operations proved the theory. Ships firing 50-plus missiles in 4 months showed exactly what sustained operations demand. The question isn't whether the Navy needs at-sea rearming. The question is whether they can make it work reliably, safely, and affordably. Early results suggest yes. The naval missile system that reloads itself at sea isn't a single weapon. It's a concept that's been impossible for 40 years finally becoming possible, not through revolutionary technology, through incremental improvements in containers, cranes, and procedures that make dangerous operations safe enough for routine use. The VLS transformed naval warfare by maximizing magazine density. TRAM transforms it again by making that magazine renewable. And when American destroyers can fight indefinitely, when magazine depth becomes a logistics problem rather than a tactical constraint, when adversaries face unlimited defensive capacity backed by industrial production, the entire calculus of naval warfare shifts. China built a navy assuming American magazines are finite. Russia designed doctrine around outlasting defenders. They're both right, for now. But when TRAM deploys, when every destroyer becomes its own rearming station, when magazine depth measures continuous supply rather than fixed capacity, those assumptions collapse. Because a weapon system that reloads itself at sea isn't just more capable, it's fundamentally different. And different changes everything.